In today's video, we are going to rewrite our radical notation in what's called rational exponent notation. So today is all about notation. We're going to be rewriting one and going from one form to the other, and then we're going to also be evaluating in the rational exponent notation form. So one thing that you definitely want out today is if you have that powers table, keep that out, and that's going to help us evaluate some of these expressions. So on my left column, I have what's called radical notation, so the nth root of some term a, and on my right column, I have what's called rational exponent notation. Well, rational exponent means a fractional exponent. So when I'm taking the nth root of some term a, I can rewrite that as a to the 1 over n. So the root that we're taking, or the index, becomes the denominator of the fraction. So I can rewrite the square root of 64. If I wanted to rewrite that in rational exponent notation, I would rewrite that as, remember, taking a square root means you have an index of 2. So this could be rewritten as 64 to the 1/2 power. If I was talking about taking the cube root of 30, I could rewrite that as 30 to the 1/3 power. And I can have variables underneath. It doesn't really matter. So if I'm talking about the 7th root of x, I can rewrite that as x to the 1/7. So the denominator of the fraction is the nth root that you are taking. So if I wanted to work backwards and give you the rational exponent notation and ask you to rewrite it in radical notation form, then I'm going to take the denominator, which in this case is 8, and that becomes the root that I'm taking. So this is the 8th root of, and my base is 3, well that's the 8th root of 3. All right. I might have two terms inside, so maybe I have xy to the 1/5. Well, the denominator is 5, so that means I'm taking the 5th root of, these two terms are both in parentheses, so that means they both go under the radical. So xy to the 1/5 is the 5th root of xy. Now, one thing you want to remember about the next two examples, if you notice, the next two examples, your exponents are negative. Okay, so you might want to just remember this rule for both of these, right? Negative exponents you want to make sure we move these terms down to the denominator of a fraction to create positive exponents. Okay, so if you remember our rules from exponents, we do not like negative exponents. So what I want to do is take these terms, move them to the denominator of a fraction so that the exponent becomes positive, and then rewrite it in radical notation. So like if I was going to take -5 to the -1/2 power, well, what that means is I don't want that 1/2 to be negative anymore. So I'm going to first start by making this 1 over, now -5 stays the same, but 1/2 will now be positive. So I've moved this term to the denominator and the exponent is now positive. Now my final answer, I want to rewrite -5 to the 1/2 power. Well, that's 1 over, my root is 2, so this is the square root of -5. And that is -5 to the -1/2 power. 10 to the -1/3. Well, I'm going to start by moving 10 to the -1/3 down to the denominator, so that becomes 10 to the positive 1/3. Then I can rewrite 10 to the 1/3. 3 is the denominator, so that is the cube root of 10. So my final answer here is 1 over 10 to the cube root, 1 over the cube root of 10. All right, so basically anytime you have a negative exponent, your answer will be a fraction, and that radical will be in the denominator. So now that you can rewrite back and forth from radical to rational exponent notation, I want you to evaluate a couple of these problems without using a calculator, and I don't want decimals. So what we're going to do is use our powers table, okay? And we're going to take this one step at a time. So if I said, well, what's 216 to the 1/3 power? Your first step is to rewrite these rational exponent notations as radical notation. So 216 to the 1/3 power is really like saying, what's the cube root of 216? Well, here's my x to the third column. So here's 216. The cube root of 216 is 6. So 216 to the 1/3 power is 6. Okay, in my second example, negative 243 to the 1/5 power. So I'm going to start by rewriting that in radical notation. So my denominator is 5. So this is going to be the 5th root of negative 243. So on my table, I'm going to go to my x to the 5th column. There's 243. Well, the 5th root of 243 is 3, but since this is a negative 243, it's going to come out as negative 3. So negative 243 to the 1/5 power is negative 3. And my last example on this page is 49 to the negative 1/2 power. So I'm going to first take care of that negative exponent. So I'm going to rewrite this as 1 over 49 to the 1/2 power. Anything to the 1/2 power is really like saying we're taking the square root of this term, which is 49, and the square root of 49 is 7. So my final answer here is 1 over 7. Okay. All right. In my next set of examples, I'm now going to take the nth root of some term, but I'm going to add an exponent. So how this changes your notation, well, we're still going to have a fractional exponent, and your denominator is still going to be the root that you're taking, but the numerator will now be a number other than 1. So whatever exponent your radical is being raised to becomes the numerator of your fraction. So if I wanted to rewrite the cube root of 23 all to the 2nd power, well, this is 23. The denominator is 3, so that's the root I'm taking. The exponent is 2. So this is 23 to the 2/3 power. If I was taking the 5th root of negative 124 to the 4th power, I would rewrite this as negative 124. My fractional exponent, the root that I'm taking is always the denominator. The numerator is the exponent. So this is negative 124 to the 4/5 power. When I'm taking the square root of something, don't forget the square root really has that index of 2 there. So if I wanted to take the square root of x to the 3rd power, I could rewrite that as x to the 3/2 power. The denominator is the root you're taking, the numerator is the exponent. So again, likewise, if I wanted to work backwards, all right, if I was taking negative 6 to the 4/3 power and I wanted to rewrite that in radical notation, what I would do is start with the denominator. Okay, the denominator is the root. Okay, so this is the cube root of negative 6, and the 4 at the top is the exponent. So I would raise this all to the 4th power. Okay, xy to the 5/8. Again, 8 is the root, so I'm going to start by writing the 8th root of xy. The 5 at the numerator is the exponent, so this is all to the 5th power. And then again, just be careful anytime you have a negative exponent. So if I had 12 to the negative 2/5, you want to make sure your first step is to move this term down to the denominator so that that exponent is positive. So I'm going to start by writing this as 1 over 12 to the positive 2/5 power. Then I can write this as 1 over, the denominator is 5, so this is the 5th root of 12. The 2 is the exponent, so all to the 2nd power. So what I want to do is simplify these 3 problems the same way I did on the front, but we have one extra step because we now have a numerator in our exponent that's going to tell us what power then to raise that answer to. So again, we want to start with our table of powers. So if I ask you to evaluate 125 to the 4/3 power, we want to rewrite these in radical notation. So I'm going to start by rewriting this and taking the denominator, which is 3. And I'm going to write this as the cube root of 125 all to the power of 4. So again, don't forget, denominator is the root, numerator is the exponent. And then it's just order of operations. You want to use your table. Inside, I want to find the cube root of 125. So the cube root of 125 is 5. But we're not done because I still have to do 5 to the 4th power. So 5 to the 4th power is 625. So 625 is my final answer. All right. If I wanted to take 16 to the 3/2 power, all right, again, the denominator is the root, so this is the square root of 16 raised to the 3rd power. Well, the square root of 16 is 4. 4 to the 3rd power is 64. So my final answer here is 64. Okay, in our last example, we have got that negative exponent. So if I want to take 32 to the negative 3/5, again, start off by moving this entire expression down to the denominator. So I have 1 over 32 to the positive 3/5. Then I'm going to rewrite it in radical notation. So this is the 5th root of 32. Denominator is 5, so that's the root I'm taking. The exponent is 3. And if I want to simplify this, I want to find the 5th root of 32. So the 5th root of 32 is 2. So this is 1 over 2 to the 3rd power. And 2 to the 3rd power is 8. So my final answer here is 1 over 8. Okay, so that's how we simplify rational exponents and how we rewrite from radical to rational exponent and vice versa.